Hello. Today I'd like to show my work for my reading project for ML theory. In particular, I focused on drifting games. Let me share my screen. So along with my report, I actually made some code, and that code essentially provides an animation of the drifting game. And what's nice is actually this code is something that can be modified in order to visualize a variety of drifting games. So the main repository is here. It's called Drifting Games. And if you want to run the code yourself, you could click on this button, Launch Binder, and you will actually be able to run the code on the internet. What it will do is it will open up this little environment where you can actually run the code. You can press play, and you should be able to run all these sections of code. Now, let me actually explain what each section does. So at the top here, there's just an import. We're using the library Manim for math animation. For the drifting game, there are several parameters that you can set. For example, there's like an LP norm, there's delta, there's number of chips, there's number of rounds, there's the dimension in which the chips are moving around in, and there's other parameters too, like the loss function or B, which is the set of where the drift vectors can be chosen from. The only parameters that can be adjusted are here. And this last one I wrote can't change. You can't change it. Now, what's kind of cool is you can actually set your weight and your drift vectors. The weight vectors are chosen by the shepherd. The drift vectors are chosen by the adversary. So in particular, W11, W12, what this represents is the weight vector chosen for chip I at time t. That's what WIT represents. So for example, here, there are two different chips, chip 1 and then chip 2, and there are three different time steps, time step 1, time step 2, time step 3. And in this case, I left it simple that all the weight vectors are just 1, 1 for chip 1, and all the weight vectors for chip 2 are just minus 1, minus 1. The drift vectors are similar in that you choose drift vectors for each chip at each time point. And in this case, I just left it so that the drift vectors are the same as the weight vectors, but these can be modified. I have some code here to actually check if the drift vectors are valid, because that's an important point. If the drift vectors are invalid, then the drifting game is not valid. So this will actually check the validity of this thing. And then here's where the main animation code actually is running. So I can press play and kind of show you what that looks like. But what it will do is after it gets the system running, it will start to actually create the animation. Now, this might actually take some time because there's a lot of steps to the animation. So I do have a video that I can show of what the animation looks like. All right, here's the video, and we can press play. All right, so that's the animation, and I can explain in a little bit more detail. We first create our plane, And then we create two chips, and both of these chips are at the origin. They're on top of one another, so you can't actually see both. Then what happens is we start round one of our drifting game. We create our weight vectors. And then we create drift vectors, and these drift vectors have to meet certain criteria. And then the chips actually move along the drift vectors. And then round two starts. Then weight vectors are chosen. Then drift vectors are chosen. And the chips are moved along the drift vectors. Okay, so thank you for your time, and please feel free to play around with this code. Thank you.